Hello and welcome again. In this, in the previous lecture, we discussed the uh, electric braking of DC motor. We have seen that there are three methods of braking: regenerative braking, dynamic braking, and plug-in. So we discussed the regenerative braking in the previous lecture. So in this lecture, I will discuss the dynamic braking. So again, you recall that the motoring operation is a situation applied voltage is greater than the back EMF and the current flows in this direction. Energy comes out from the source and absorbed by the motor, and this converts this energy into mechanical energy. So this is a normal operation. And if you want to go for braking, dynamic braking, what you have to do is simply you have to remove the terminals of the supply and connect it through some braking resistance. So what happens is that the equation for the speed versus current in the normal operation is like this: V upon K minus RA upon K IA. So this is the normal case equation of speed. Now when we reduce the voltage to 0 and short circuited by some braking resistance, then this term will become 0. So you will get RA plus RB plus upon K into IA. So this will be the equation, and as you can see that the current will now flow in the reverse direction. So current is now negative. So this is equal to the current that flows here will be equal to E upon RA plus RB. I will explain the need of this braking resistance also, because you can directly short circuit it, then also you will have some current in the reverse direction. So what happens is that, so this is a normal operating characteristic of the DC motor, and you are operating somewhere here, and you suddenly wanted to stop the motor. So what you will do in that case? You will, if suppose you don't use this braking resistance, then what will happen? You just short circuit it. So if RB is not used, or you can say that the braking resistance is 0, and you just short circuit it directly, then the current that will be flowing in the reverse direction will be equal to E upon RA. So this is almost same as supply voltage upon RA. The same current that would flow if you start the motor directly online without any starter. So this will be equal to, almost equal to the starting current of the DC motor. That is very high, maybe 20 times or 30 times more than the full load current, and that is dangerous for the motor and it should not be allowed. So that is why instead of directly short circuiting it, we have connected a resistance here such that the current is within the safe limits. So this braking resistance is connected. So what you have to do, simply remove this supply and short circuit or connect a resistance RB across the armature terminals. So this will make this equation, and the equation for the speed will become like this. So how the characteristic will change? Now same, this was the normal characteristics for rated voltage. Now here the voltage is 0, only resistance is there. So equation is Y equal to mx, C is 0. So this means that it will somewhat like this, a negative slope. So what happens is that you have to add, you have to use such a resistance RB that current is within the safe limit and it is near the maximum permissible current. So suppose for that motor the maximum permissible current is twice the full load current. So you can add such a resistance that the current is equal to twice the full load current. So the characteristic of the motor for this resistance RB will be like this. So this is the slope, a negative slope, minus RA plus RB upon K is the slope of this characteristics. So you are operating here and suddenly you have made this change. speed will not change instantaneously. At the same speed, on these characteristics with resistance RB, you have this operating point. So as soon as you do this, current reverses and becomes equal to twice the full load current, and you have a torque which is twice the full load torque of the motor in the reverse direction, because Ia is now opposite, so the torque is also negative. So because of this negative torque, the motor will start, the speed of the motor will start decreasing, and you will move somewhere like this. But you want to quickly stop the motor. As the motor's speed decreases, the current decreases. Current decreases means the torque will also decrease. So the braking torque will also decrease. So you want to maintain a high braking torque. Then what you have to do is that as the current reduces, suppose near the full load current, you again reduce the resistance. If you reduce the resistance, then the slope of the curve will decrease. So you will have this characteristics for, you can say, RB1, the original resistance, and then you have made it RB dash, which is less than RB. So you have reduced RB such that the current again becomes equal to the twice the full load current. So again operating point will shift here. Again the torque will increase to twice the full load torque. Current will become twice the full load current. Again the more torque is produced and the motor speed will decrease more sharply. And again here, reaching here, you can again cut out the resistance to RB double dash, and again the torque will become twice the full load torque, and the motor will decelerate quickly, and finally it will come to standstill here. So this negative will not be there, because as the motor speed becomes equal to 0, then E will also be equal to 0 and no current will flow. So this is the case of what is known as dynamic braking. So if you compare this method with the regenerative braking, you can see that in this case the energy which was stored in the mechanical system of the motor, the kinetic energy, will be released and it will be absorbed by the braking resistance and the armature cycle resistance. So the energy which was ever stored there is wasted in the form of heat across the armature cycle resistance and the external resistance. So this is inefficient method as compared to the regenerative braking method. So this is what is known as dynamic braking, and you can see that you have to reduce the resistance gradually. For that you can use the starter that was used during starting. The same starter can be used during braking also, because the resistance, the current that the motor draws is same as the starting current. So you can insert the same resistance that you used when you were starting the motor. So that same starter can be used, and you can reduce the braking resistance gradually in steps, so that enough braking torque is obtained and the motor stops quickly. So this is what is known as dynamic braking. Thank you.